Hi everyone, and welcome to TLDR Week 3. This week we're going to be talking about app installs, updates, repositories, and file management. The learning outcomes for the week: I want to make sure that you are able to install applications, update a server, explain how a repository works, why we have them, explain about the different types of repositories, and describe some default configurations for some basic setups. One of the first things that we want to talk about is file access. What you can see on the screen right now are some examples of common commands that you might end up needing. For example, chmod, which can be pronounced with either a hard ch type sound or a soft ch type sound. I've always heard it pronounced chmod, but I know other people will pronounce it different ways. And chmod will allow you to change file permissions. You can also do things like change attributes of a group or change file owners. Directories. When we end up having a directory on a system, you can see that the first character of the line, if you run an ls-l, is going to tell you if it's a file or a folder. There's something called a sticky bit where you can indicate if permission is to only let the owner or the root delete or rename the file. You can also use sys.d. Technically, you can use this to run a script as root, but a lot of current systems will actually not allow you to do that as it is a security vulnerability. The SUID is basically to set the owner user ID when you are executing it so that you can have different things run under different owners if different owners have different permission sets. What I'd like you to do for an activity to do some practice is try each of the commands that were listed under the first slide on file access: chmod, change group, chown. I'd like you to try practicing changing the sticky bit and setting an SUID. Feel free to pause me now and come back after you've done these things. In Linux, the file system uses something called inodes. The way inodes work is you basically have a small table with a pointer to a data block. One of the things that makes inodes really powerful is we can actually have pointers to pointers, which will then point to data blocks. These are considered indirect pointers. So what you can end up having is a table that has a pointer to another table, which will have more pointers, so that you can end up having a larger set of data blocks. In practice, this means that we can have larger files than we might be able to have under something like a FAT16 or FAT32 system. When you're talking about servers, it's really important that you have a disaster recovery plan in place. There is a difference between Windows and Linux file deletion. Sometimes when we talk about deleting files, it's actually just deleting the pointer to the file and marking it as able to be overwritten. However, sometimes the file is actually deleted, and it's important that you know what your system does. It's also important that you think about, if something does happen to my server, what is my plan for that? You never want to plan on nothing going wrong, because at some point something is going to go wrong, and it's better to have a plan in place when everything is calm. You want to think about things like system failures or power outages and what your backups are going to be. If you are, for example, running a mission critical system such as a server that manages finances for a bank, it's really important that you are never just saying, "Oh, I'm so sorry, we can't actually manage any of your money right now because all of our servers are down." That would not be an enjoyable situation to be in. Now, all of your systems are going to have system files. Some will have all of these, some will have some of them. You should have two servers set up by this point, a CentOS system and a likely Debian or Ubuntu system. Some of the common system files that you're going to see is things like the bin folder, the etc folder, the home directories folder. You're also going to see some special files. An example of a special file is dev null. This immediately discards info. It's basically a black hole. So if you send things to dev null, you're sending them to the black hole of nothing. You might also see a proc file. This is considered an illusionary file system. It's the equivalent of a task manager from Windows. The next thing that I'd like you to do is go find each of these files in your system, write down where they are, start giving them a little look without changing them. Feel free to pause me now and go do that. There are some tools that you are very likely to use on a frequent basis. One of the things that ends up happening with Linux is you will frequently see that Linux systems have multiple ways of doing things. So there are usually a couple of different ways you can go about solving problems, and usually whatever you know how to do is going to be the way that makes the most sense. So part of what I'd like you to do as you are going through this class is start looking at different options such as some of the power tools like Sed and Awk, and some of the commonly used commands like grep so that you can start practicing with them. If you start practicing with them, it'll be a lot easier to have them come to mind when you have a problem that they might be good at solving. There might be a lot of other ways that you could go about solving the problem. For example, awk. Awk can work with text processing. It's usually used for data extraction. You can actually write awk scripts. One of the things that makes awk so powerful is you can use regular expressions or regex. Now, once you have gotten over the learning curve for regex, that's actually a really powerful thing that you will be able to get quite a bit done in a very small amount of characters, but you have to be comfortable with it for that to be a tool that you reach for. So I'd like you all to make sure that you are practicing with that. Some examples of Sed and Awk, we can do things like print every line or print only lines that match patterns. We can also do things like make changes. So in the example of Sed, we can actually in one small line make a change where whenever we see day, I want it to be changed to night, and then save those results into a new file. That's actually a quick and easy thing that Sed can do. There's a lot of other ways to do this, including manually going into the file, but once you get practice with it, this will become a lot easier for you to think of as one of your first solutions. You can also see an example of an awk script that's squares. This is not a particularly good real life example, but this is an example that you'll see a lot of people use in awk. Some examples of scripts that you might end up wanting to write is things like creating a backup script so that you can back up things on a semi-frequent basis, perhaps set it up as a cron job. You might want to have a disk usage report so that you can figure out how your hardware is doing, a little quick check-in to see if anything needs to be updated. You might also want to do things like write a security monitor so that you can see if there are any programs that are running that perhaps you do not want them to be running the way that they are. Next, we can start talking about repositories. Repositories are used to collect and organize software. When we have a repository in Linux, that's one of the ways that we're going to easily install new things. If somebody has created a new program and they put it in a repository, that means that you will be able to install and access that new program quickly and easily. You can also do something called a personal package archive or PPA, where you can actually create your own repository or you can have your code there to easily share with others. One of the big things that a repository is good for is it's software that's compatible with your system. One of the big negatives to Linux is there tends to be a lot of software that isn't really compatible with your system, and a repository is a way to collect all of the software that is. We can also do things like, for example, split software by version or kernel. It helps us to keep all of our software compatible with our system, and this is also a place that we can host operating system updates so that we don't end up with things like Update Tuesday, where updates are forced and pushed to us rather than pulled from us. Some common repositories. There's standard and non-standard repositories. Standard is usually what comes with your machine and it should work without issues. Non-standard means it's being added separately. This is kind of the equivalent of the wild, wild west. Who knows what you're going to get. You can have a non-standard repository that is perfectly safe, has great code, and is compatible, easy install. You can also have something that will completely foobar your system and you don't really know unless you are the one that created the repository or it's done by somebody reputable. Ubuntu has some slightly different vocab. The universe is community maintained. The multiverse is restricted by copyright. The main repository has your supported programs, and the restricted means that there's proprietary information in there, such as device drivers. For a quick activity, I'd like you to go in and find your repositories. What's already on your system and why is it there? Feel free to pause me here while you go do that. If you're going to add a repository, there's a couple different ways that you can go about doing this. You'll need to use sudo when you do this. Make sure that you know how to add and remove repositories before you continue. It is important to think about repository safety. Unknown repositories are a safety risk because they allow installs on your system. This is the equivalent of basically going around the internet and saying that you would like to install the best whatever it is software and clicking on the first link. You know that that's not a safe thing to do and that's a way to get malware. Same thing with unknown repositories. Think about your trust in the person hosting the repository and how popular it is. If this is a popular repository or PPA and a lot of people have used it safely before you, that's generally a better indicator than if only one or two people have used it. Think about how up to date it is. Is this well maintained? Are people troubleshooting on it? Or is this repository from back in 2002? Another thing that you want to think about if we're talking about repositories is your own personal comfort when we talk about troubleshooting. How comfortable are you troubleshooting things on your Linux system? If the answer is not very, you need to take extra care when you're adding repositories because that can be more dangerous. If you are relatively comfortable troubleshooting, you might be able to be a little bit more free with adding repositories. Then you're going to want to think about if the repository is still in testing or if it's production ready. Are you an alpha tester or a beta tester, or is this just generally ready? And that's a personal comfort level and the amount of risk that you're willing to take. When we talk about patching, we're talking about fixing a critical error. An update is an overall change to the system. It's important that you're paying attention to both of these because they can both cause issues if they aren't tested. A lot of server admins actually test updates and patches before sending them company-wide. It's completely possible that an update or a patch will break your system or be incompatible with programs you already have installed. For example, let's say you are a sysadmin for a large company and they have an accounting department. If the accounting department is running a previous version of, say, QuickBooks, because that's the one that's compatible with their machines, and you end up pushing an update that breaks that, you could potentially take the entire department out of work for an unknown amount of time until you fixed it. But if you do testing and make sure that you're testing on each of the environments, you'll be able to head that off and you won't have to worry about downtime. You just have to worry about testing and troubleshooting for you instead of an entire department who can't work for an unknown amount of time until you fix it. That's a very stressful place to be in. Then you want to think about hardening your system. It's important to harden your system or give it some more security so that if you have a system that is publicly accessible, you are not asking for trouble. Some examples of hardening systems can include locking your hardware or doing BIOS password locks. It's important to do file system anomaly checks, such as are you missing partitions. You want to make sure that you are checking your repositories semi-frequently. This is actually a really good use of diff so that you can see if anything has been changed or been added to. You want to make sure that you know about all of the changes and updates and you're including them in your documentation. It's important to check your installed programs and services, see if anything is up to date, if patches are there. If you have programs or services that you are no longer using, it's important to remove them if they are no longer required. You want to think about doing things like checking ports and protocols. Do you have SSH access enabled? Do you need it enabled? Do you have a root login check? How up to date is your system? Has it been patched? New vulnerabilities are found all the time, and you want to make sure you're protected. If you have a system that uses SE Linux, it's better to enable it if it's possible, but that's something that can sometimes create problems depending on the other pieces of your environment. You want to make sure that you're paying attention to your user password rules. Think about what we talked about last week in user password rules. Are the user password rules that you've come up with actually the thing that happens? And then the most important follow-up question is, are my users actually following this set of rules or not? And you want to think about, if your users aren't following your password rules the way that you would like them to, why and how can you fix it without being a punishment to your users? You want to make sure that you have log monitoring and auditing. This means that you want to keep track of everything that has happened on your system and then go back and look at the logs to see if anything funny has happened. You're going to want to think about backups, what your setup is for that, and you're also going to want to look at your firewalls or IP tables, which we're going to have a little bit of time to look at later. Now, the assignment for the week is you're going to continue your setup and continue your documentation. You're going to check the repositories that are on there. You're going to do a couple of installs of programs. These may or may not work right out of the gate, and you might have to do some troubleshooting. I'm also going to have you practice doing an update, and you're going to continue working on your documentation. I'll include the exercises as part of the description for this video. Please let me know if you have any questions.